Hi everyone. In this video we're going to cover extended ACLs. So extended ACLs are just like standard ACLs. You have an action, which is permit or deny. You have source IP address. That's either a host, a single IP address, or network. But then you also have what kind of protocol. So like TCP, UDP, IP, which is basically everything, ICMP. You have destination network or IP address. So once again, host. And then the port number. So like port 80, 443, which is HTTP, HTTPS, SSH. You can put in a single port if you wanted to. And just like with standard, you can use numbered, which is 100 through 199, or 2000 through 2699. Then you have named, which is the same as named ACL. You can put in, Steve ACL. Now, just like with standard ACLs, if you use a numbered ACL, whenever you try to modify it, like delete anything in there, it deletes it all. And you have to recreate the whole access list again. It's a pain. Named ACL, that's where it's at. That's where you can modify things, add removed ACEs, access controlled entries, and only remove that one ACE and not worry about removing the whole access list. So much easier, so much better. Oh, this right here, UDP. Alright, so let's draw a network. As you may know, I have a talent for drawing. So let's draw some circles. Almost got it that time. Let's draw our networks, our computers. Everything's connected. Our interfaces are right here. This is, PC1, router 1, router 2, PC2. Now, with standard ACLs, we want to put it closest to the destination. With extended ACLs, it's the opposite. We want to put it closest to the source. So why is it that we want to put it closest to the source? Because, I don't know if you watched the standard ACL video, but you might block things inadvertently. You might accidentally block things. So if you put it closest to the source, there's less of a chance you're going to block things by accident. So let's say we want to block SSH from PC1 to PC2. So here's going to be the source right here, and here's the destination. Traffic is going this way. So what is the closest interface to the source that we can apply this ACL? Right there. So the closest interface to PC1 is where we're going to apply it. And then when we configure the ACL, we're going to configure it so that way it has as much detail as possible. Source network, protocol, destination network, port number, as much detail as possible so that way we don't accidentally block the wrong type of traffic. Alright, so let's go see that in action. So here's the network. We have PC 0, router 0, multi-layer switch 0, PC 2, which is in sales. We don't like them very much. We want to kind of protect everybody else from them because we know sales, they download lots of viruses. We have PC 1 and IT. Unfortunately, IT has to be close to sales to fix all their issues. So here's configuration on them. If you watch the standard ACL video, it's the same configuration. Router 0, one thing I did here is I configured the interfaces, configured a default route. Multi-layer switch. One thing I did here, created a username, enabled routing, domain name. This is all for SSH stuff. Configured the interfaces as access ports and put them in VLAN 10. Obviously, I had to create a VLAN 10. Made gigabit Ethernet 01 a layer 3 routed port, put IP address on it, SVI 10, put IP address on it, and then a default route. Configured VTY lines, made sure that only SSH can be usable, and then login local for SSH. So we want to block PC0 from accessing PC2 in sales. Now there's two ways that we can go about it, and it depends on what your needs are. You can either block PC2 from accessing PC0 or block PC0 from accessing PC2. It depends on, like I said, what your use case is. What is it that you're trying to do? In this case, we're going to block PC0 from accessing PC2. So the closest interface to the source, that'd be gig01. So two different ways to do it. First, we're going to use a numbered ACL. So access list. Put it in the extended list here. Let's just say 150. You can do your permits and denies or remark. Remark is just a description of what it does. So remark bad sales, stay away. And then we have to do all over again. Access list 150 per, let's say, deny. What is it that we want to deny? We want to deny ICMP. Then we want to deny what's our source address that we want to deny from. And that's 172.16.0.10. Now you could do a range, or you could do just the host, and you put in host there. Then what's your destination? Destination is going to be PC2. So once again, host 192.168.0.11. Now once again, we could put a network in there if we want to block the whole network, but we want to make sure that we can contact IT. And then of course, you can actually specify what you want to block. Is it just echo reply, or everything? And this right here, I'm just going to do echo, just because we're going to block pings. And that's it. So let's apply it now. And now remember, with ACLs, there's an implicit deny all, deny any on this. So if we applied this right now to the interface, we'd have this one statement denying access to PC2, but then we'd be having that deny any at the very end of it. That's invisible, you can't see it. So it'd block us from PC1. So we have to put in a permit statement. So we can permit ourselves to access PC1, but then let's let the deny any take effect and block us from accessing, let's just say, the gateway for PC1, PC2. So permit, access list 150 permit. Let's go ahead and permit anything to PC1. Host, this is our source, 172.16.0.10 to our destination, host 192.168.0.10, and we can choose what to put in there. We're just going to say anything, everything and anything can access it. Access list 150. Now once again, there's an implicit deny at the end. I'm just going to show you what it looks like. Deny IP any. That's it. This is what you can't see at the end of every single access list. Deny IP any. Alright, let's apply it to gig01. Question mark 150. Now which direction? You want it on the inbound direction. Why? Because it's coming in to the interface. All right, now let's see if we can ping. Let's try this out. Ping 192.168.0.11. Can't do it. Let's see if I can get to 10. Yes. Let's see if I can get to 1. No. Well, let's see if I can even get to my own gateway. Let's see what I can get to. I can't even ping my own gateway. Why? Because of that implicit deny any at the very end. We're only permitting ICMP from PC0 to PC1, but to nothing else. So I can't even ping my own gateway. So that is an example of a very bad ACL. Normally you'd have a permit IP any or something to allow traffic to go out. Alright, so we are denying access to PC2 and also everything else and only allowing access to PC1. Let's fix that. Do show access list. Here we have this. Once again, if you want to modify or edit one of these rules, you have to delete it and recreate it to be able to do that. Not the funnest. Not a lot of fun at all. So, numbered ACLs aren't exactly fun. Let's use a named ACL. Let's go ahead and remove this. Let's put in a named ACL. IP access list. Extended. Our name. Let's say bad sales again. Then of course ACL. And then say it's going to be in. So when it comes to ACLs, it's up to you to figure out what is the best way to organize the ACL so that way it'll do what you want it to do. The last ACL was a very bad example because it blocked traffic to everything, your own gateway, any other service that you need. You're only allowed to access PC1 and that was it. So one thing to do is figure out what it is that the ACL is going to be doing. What is it that you want to allow? What is it that you want to block? And then of course configure it accordingly on whatever is easiest to configure. So for example, in this case, it's easiest to just say deny access to PC2 and then permit everything else. So deny, I want to deny ICMP. You can say any. Let's just say any, so that way anything on this interface can't access PC2. We're going to go to a single host, 192.168.0.11, and then we want echo. Now, we also can do a type number here. And also, I just want to put in a permit. Just say IP, and permit anything going to anything. But let's just say, just for fun, this network, 192.168.0.0, wildcard mask. So this says permit any protocol from any source coming on this network, coming onto this interface, to this network. So our first ACE, we blocked access to PC2, and now we're saying allow access to everything else. And now we still would have the issue of we cannot ping our gateway. So we need to make sure that we can actually ping everything that we want to. We want to be able to access anything that we want. So a lot of times at the end of ACLs, you'll see this. Permit IP any. Do show run. Here's the access list. Now let's just say that we want to also permit port 80, HTTP. Permit TCP. And we can say host 172.168.10. Let's just say it's going to go to PC1. We're going to allow HTTP to sales because we all know that sales would never take advantage of that. So right here, EQ, you can match only on packets matching this port number. Now, TCP has lots of port numbers within it. Now you can easily do a bunch of other things greater than port number. So if you put port 80, then anything above 80 will be allowed. Lower, anything below 80 would be allowed. Anything that's not on port 80, so anything but port 80 basically is like, the reverse logic. And then range. Have a range of port numbers. But we're just going to do a single port number. And you can do any port number in that range. Now there's some stuff here that is kind of easily done for you. So like www is pretty old. I mean, World Wide Web, come on now. But you can put 80, you can put www, both will work. I just like putting in the port numbers myself. Do show run. Here we are. So now what this ACL is going to say is, I cannot ping that sales computer, but I can access anything else on there. So this right here will actually incorporate that. So this right here will never get used because of this. And then of course, I permit IP in any. There is a catch-all. I just put this right here in there so that we could see this last part. So once again, this right here is not a good real-world example. It's just me kind of going through each type of ACE so that we can kind of see EQ. You can see permit IP in any. You can see doing things with wildcards. All right, now we have to apply it. Once again, closest interface to the source. IP access class or access group. Bad sales ACL. And then in. Let's try to ping again. I can ping my gateway, that's good. I can ping .10, but I cannot ping sales, which is what I want. All right. Let's say that we don't want sales to access PC1. We don't want them to access IT. Now, granted, this is a bad design. You never want to put any other departments with sales. Why? Because sales is click happy and you want to put them off by themselves. All right. Let's create an ACL here because we want it closest to the source, and the closest to the source is SVI 10. So IP access group, access list, sorry. Extended, I want to use the named again. Bad sales, ACL, and then we want it to be in. Now, one thing to keep in mind is we're going to apply it to this interface. We have two different departments using the same network. So we have to be careful on what to do to apply that ACL, how we configure it. So let's just say we want to permit IP. Let's just say ICMP. Host 192.168.0.11 or 10 to any. And then we can do echo, or we can just say that's it, just permit ICMP. And then we want to deny sales 2. Now once again, we could just leave it at this. Let's say there's other computers that we want to permit as well. You can either put this deny on the top and block sales and then permit everything else, or put in several permit statements for everything that you want to permit. It's up to you, whatever is best for you. But always try to make it as fewest ACEs as possible. Let's just deny just for fun. Deny ICMP. Notice 192.168.11 to any. Let's apply it. Do show run. See, here it is. Now this right here is not really needed because there's that implicit deny any at the end, but just put it in there so that we can see. And it's always fun to block sales. and VLAN 10. So we are now on the SVI IP access group. Question mark. What's the word? It's bad sales in. And then of course in. Now, why do I always put this ACL and also the direction in there? Well, because whenever you do this, and you're looking through configurations, you see this access group here, bad sales, you know what it is. It's an ACL, and it's in the in direction. And even though this command right here says in, it's like, oh yeah, of course it's in. Well, sometimes when you have lots of ACLs and it's late at night, early mornings, or it's just one of those days where you're foggy brained, it's always good to let yourself know which direction it should be applied in. And of course, you just copy that and put that in there. So do what you can to help yourself for when it's in the future and you're not as clear-headed as you are now. So let's see if I can ping it. Actually, I have a better idea. Let's say no to this. Actually, no to this. We want to deny that to, there we go. So we just want to deny PC2 to PC1. That way we can still ping out, and then we can say permit IP any. That way PC2 can still ping across the network. See what's applied. It is applied. Excellent. Here's my access list. Let's make sure that there's no ACL here. Now let's see what happens. I can still ping. Now, why is it that I can ping PC2 to PC1 even though I have a NI right here between the two of them? The answer is because it never goes through the SVI. One thing you need to be careful of is that this access list is only applied to the layer 3 interface right here. These are on the same network. They don't ever go through the SVI. So even though we want to protect IT from sales, we can't do it with this type of ACL. There's another type of special ACL for layer 2, but we don't want to get into that right now. And so when it comes to ACLs, you want to make sure that you kind of visualize and map out how do things flow. Because these are on the same network, they never cross a layer 3 boundary where the ACL is applied, right here on SVI 10. A better design would be just to take sales and IT and make sure they're not on the same IP networks. So that way you do have to cross a layer 3 boundary. Alright, that's it for this video. Let me know if you have any questions.